basic derivatives, quotient rule, Lagrange's notation. So, what the quotient rule is, the way Lagrange does it, or Lagrange, however you say it, is he has a function, and within this function is another function over a function, or a function divided by a function. In this case, it's hx equals fx over gx. Now, when you derive this, you end up with the derivative of hx, which equals the derivative of fx multiplied by gx minus fx multiplied by the derivative of gx. And all of that is over gx squared. Now, a very simple example of the quotient rule, or how to apply the quotient rule, would be over here, where you have a function and it is equal to a function, which is x, over another function, which is another x. This is very simple. You can do other ways much quicker, but we will not focus on that. That's just a way of making a connection. I will do an example to help solidify this. So, let's start. Example 1. hx, make it equal x squared over x plus 1. So, hx, when you have a function over a function, use the formula fx over gx. Now, they look very similar because there's a function there over another function, and there's a function over another function. So, we can make a connection by calling fx x squared, because this is on the top and this is on the top. So we'll make the connection between those two and make fx equal x squared. Now, do the same thing with the bottom. Gx, we'll make that equal to x plus 1. Now, the derivative of h, x, is the derivative of fx multiplied by gx minus fx multiplied by the derivative of gx, all over gx squared. So, what it says here is that we need to find the derivative of fx and the derivative of gx. So, the derivative of fx is 2x, and the derivative of gx is just 1, because 1 gets away and derivative of x is just 1 anyway, so it's just 1. So if we sub that in, what we end up with is derivative of fx, 2x, multiplied by gx, x plus 1, minus fx, x squared, multiplied by gx, which is just 1. Now you can cancel that out because multiplying by 1 is the same as what it is, so just leave it if you want to. And then we put all that over gx, and then we square it. Now, you can go further, but I'm going to leave it there because that's derived. You can just simplify it and make it look nice, but I'm going to leave it there. Do another example. So, let's say x to the power of 3 plus 4 over 7x squared plus 5. Now, again, that looks like fx over gx. That's a bad g, but you get it. So, we label them accordingly. Fx is on the top, so we label it what's on the top over here. And same with the bottom, we label the bottom and the other bottom. So, the formula for the derivative is the derivative of fx multiplied by gx minus fx multiplied by the derivative of gx all over gx squared. So we need to find the derivative of fx and the derivative of gx. Yet again, up here, in our little sectioned off bit, we'll bring the 3 down and make it 3x squared, and you cancel the 4. So it's just derivative of fx is 3x squared, and the derivative of gx is just 14x, and that's it. All to the power of 1, but I'm going to leave it off. So, if we sub that in, what we now have is fx, 3x squared, multiplied by gx, 7x squared plus 5, minus fx, multiplied by g dash of x, which is 14x, all over gx, which is 7x squared plus 5 squared. Now you can make it look pretty or simplify it further. I'm going to leave it there. Looks pretty enough to me. And do another example. So for our last example, hx equals x squared over 5x to the power of 5, take 10x plus 3. So, again, label the top and bottom as accordingly. Function over another function. fx equals, make it equal to x squared, and gx will make it equal to 5x to the power of 5, take 10x plus 3. If you can fit that in. Yes. Okay, so derivative, the formula for the derivative is derivative of fx, again, multiplied by gx, minus fx, multiplied by the derivative of gx, all over gx squared. So again, we find the derivative of fx, which is 2x, and the derivative of gx, which is, bring the 5 down, 25, x to the power of 4 minus 10. So if we sub that in, what we have is 2x multiplied by gx, f dash x multiplied by gx, which is 2x multiplied by 5x to the power of 5, minus 10x plus 3, minus fx multiplied by g dash of x, which is x squared, multiplied by 25, x to the power of 4 minus 10, all over gx, which is 5x to the power of 5 minus 10x plus 3 squared. And that there is the first derivative of this up here. Thank you.